Good afternoon, everyone. Welcome again to this class. So, talking about network and network security, our main area of interest is network security. But we are going to be talking about, we can't talk about network security without understanding what networking is. Yeah. Prior to now, I could have advised us to go for a course, but the course is going to take good amount of time. I think on Cisco network is about 45 hours. Ordinarily, we need to have, like, let me say, a very solid idea of what networking is before we now delve into network security, because you need to understand. Take, for example, you want to do a course and the course is bank security. You need to understand what bank security is before, you need to understand what bank is before you now learn about the security. I don't know if I'm making sense. Now, I will break it down to a very simple. I'll break it down in a very simple way. First of all, network. When you connect, let's say the way I'm standing now, I'm holding Christiana. Christiana is holding another person. We are connected together. So you can call that like a network of persons. That's the same way you can talk about devices, not necessarily computers, devices. It could be a Bluetooth device with a mobile phone. That's like that's a network. Both of them are already networked. It could be, let's talk about our home. It could be our electric. Let's say we have like an electric gate connected with the Wi-Fi network in the house, connected to the CCTV cameras, connected to the television. That could be another network. So just know that when something is connected to another, we are talking about a network. That's the simplest way I can give that explanation. Moving further, let's talk about network topology. So network topology is just like the physical. If you don't want to use physical, physical is something you can see. If you don't use physical, then we can talk about logical. Yeah, either physical or logical. Yeah, arrangements of nodes. They ask you what's a node. In the course we did that. Remember, I've forgotten a node, but okay, yes, I remembered. Is it not? I think biology or so. When they talk about node, then is it anti-node? Like one point. I'm trying to bring the idea of biology to this place. I think a point, then another point, then the difference between those 2 points. I think they call them anti-node or something. But in computer, a node is like a computer, like a device. Yes, a device. It could be a computer. It could be a switch. It could be a router in a network. Okay. So network topology, like what you are seeing on the screen currently, is the physical or logical arrangement of nodes. That's the way you arrange those nodes. You can see on the screen now what we have here. We have bus, we have star, we have ring, we have mesh. There should be hybrid. Hybrid is when you connect two or more. That's two or more. The hybrid. Okay, now I don't need to explain each and every one of the things you are seeing here. It's self-explanatory. Yes, line, you can see the way it's arranged. I think this line, I'm not sure you can see this line in Facebook. I think it's boss. You always see boss. You can see the way it's arranged. From this arrangement, you can deduce the advantages and the disadvantages. I don't know if I'm making any sense. Let me just take one, for example. Let's take boss. I'm not explain everything. I'll just take boss, for example. Look at the boss now. You can see that all the devices are connected to a single backbone cable. Now, what do you think is the advantage, or what do you think are the advantages? We have, like, it is very easy to install, definitely, and I'm sure something that is easy to install is cheap. Now, what are the disadvantages? If you look at it it's difficult to troubleshoot. What does troubleshoot mean? Troubleshoot means when you want to detect what the problem is. That's what troubleshooting means. Yeah. So now one you see, we talk about this thing. All of them are connected to one backbone cable, right? If that backbone cable should break, just imagine it breaks. Trust me, the whole network can go down. So we can use that understanding to look at every other one of them. Now, let me give you one fun fact, or one interesting fact. if you know NASA, if you know of NASA, these guys that do space, whatever, they use mesh topology. This one is here. And the reason why they use mesh is what? Ensure data redundancy. What redundancy is like take for example now, if one node should fail, the system will still be able to intercommunicate. That's the importance of that data redundancy. Let's talk about the advantage and disadvantage of this mesh. Looking at it now, you discover that it's actually robust, so we can say it's not easy to install. You get, as it's not easy to install, definitely is expensive. And just going for that, for the sake of those people that probably want to write ISC2 or CCNA or any kind of exam you're going to write, maybe any cybersecurity exam you're going to write. So yeah, now the disadvantages you already know. Something that is like this is complex. Something that is like this is expensive. Yeah. So let's proceed. So now, talking about different kinds of network that we have LAN, we have WAN, we have the internet. That should be okay. These guys started with LAN. Let's start with, there should be PAN. PAN is like personal area network. Yeah. Then there is LAN. Then there is WAN. So that I wouldn't be explaining too much. I need somebody to please help me. Just talk about a LAN. Just talk about a LAN. Anybody? Talk about a LAN. Floor is open. Don't raise up your hand. Okay, Oluwadam Larry. A LAN. Please unmute and speak. Okay, he's not here. The next person I caught. Joyella. What's a LAN? A LAN.
Hello, good afternoon, sir.
Yeah, good afternoon.
If you can hear me, okay. So a LAN is a local area network. It's just for it's a specific location. Let's say a house, a school that just interconnect that area. It's not like a wide area network. It's just within a small space. That's just what I have to say in my own lane.
Okay. Okay. Yeah, Joy, please still stay on the call. Like, stick your mic open. We'll make it a bit conversational. So once we converse, we are done with this aspect. Do you know? Have you heard of PAN, Personal Area Network?
I'm just hearing of it now. We're always taught LAN
Okay.
and WAN. I'm just hearing of PAN now.
Okay. Have you heard about MAN? I think that's the Metropolitan Area Network.
Area network is a
Okay, please, everyone, just listen to the conversation. Via this conversation, we are going to explain all these things completely. Joy, if me and you we are in the same office now, let's say we are in the same office, what kind of network do you think would make sense to use?
I think the best network to use is the LAN.
Yeah, confirm, that's correct. Now, what if you are in which state do you reside in?
Abuja.
Okay, you're in Abuja now, and
Yeah.
let me say me in PH. What kind of network do you think we are meant to use?
We're meant to use MAN.
Okay, Metropolitan is mostly, let's say, in a city, just like in a city. Now, like across like wide area. Sorry, I've already said it's one actually. Yeah,
It's
but
one,
thank you very much.
All right.
Yeah, it's one. Thank you very much. So the conversation already explains. The conversation already explains what LAN, WAN. There's also MAN. It's not written here. There's MAN. There's PAN. Then the internet. See, the internet is alternatively called WAN. Yeah, alternatively called WAN. So let's quickly talk about the internet, because all those LAN, man, you can just go and read them up. That's if you are interested, you can read them up. Our area of interest would be internet. Um, our area of interest would be the internet, because that's majorly what we are going to be doing. Although there will be a time you are going to hack, and it's still not when you are going to do this Wi-Fi hacking, it's not under LAN, it's still going to be under WAN, wide area network internet. You already know what the internet is. As a matter of fact, you are listening to this call via internet connection. Yeah. So I don't want to run you guys through the history. Yeah, but just know that it started with all these static HTML pages to interactive web apps like we have now. Now let me bust you. Do you know that there are more devices connected to the internet than there are people on Earth? Let me come again. There are more devices. When I mean device, I mean laptop, desktop, phones, what have you, tabs, and the likes of that. There are more devices connected to the internet than there are people on Earth. Yeah, I think can't remember the number. I think over 5.4 billion users. So yeah, so that is that about the LAN. About WAN as the internet. We are still going to look at it in more details. As a matter of fact, the material I gave you explains it all. So the picture you can see on the screen currently is talking about LAN. If you look at it very well, you understand what LAN is, a local area network. 1 minute. Next on our slide, we have network. Next on our slide is network components. 1 minute, my PowerPoint is taking time to load up. Good. So now, please, all these aspects, they are also important. Network components are those components of our this thing that enables this network interaction or communication. So we have network interface card. Please, we have the definition on the slide. There's no point in me reading it again. We have switch, we have routers. For those of you that have actually worked in an organization whereby you were dealing with the networking devices, there's no way you would have come across switch. There's no way you would have come across router. You get, and you should have seen a NIC card before. Okay, let me explain what this thing what it does basically. Let's say I have a device. Let's say I have a Starlink. Now, okay, let me use a Starlink. Let me use MiFi. I have a MiFi, like a small MTN MiFi. Ordinarily, MiFi should have a maximum number of users. Now, those that want to connect to that MiFi, they're actually exceeding the maximum number of users. There is need for me to amplify that stuff, like the number of users. That is where a switch comes into the picture. It connects multiple networking devices inside a single LAN. Now, there's a situation whereby I want to amplify. Let's say I want to amplify the signal strength. Let's say I'm carrying the network from, let me say, building A to building Z, very far place. You will discover that we don't just need a switch here. We don't just need someone that will just like interconnect. You see where a router is coming to play a very big role. For the sake of this course, we will not go into details. Like we won't talk about those one in details. We'll just scratch it at the surface. So let's proceed. Next on our slide, we have talking about WAN. Now, we have wired versus wireless network. We already know the difference between a wired network and a wireless network. In our homes, as if I'm not mistaken, probably some homes they do something different. But in our homes, most of the time, what we use is wireless network. I want to connect my phone to my laptop. I want to connect my laptop to the television. Most of the time, it's always wireless network. But then, in offices, in corporate organizations, what they use most of the time is wired connection. Please, I need somebody. I want to engage in a kind of conversation with someone that would differentiate between a wired and a wireless network. Anybody? Okay, Don Emerson. Difference between a wired and a wireless network.
Okay, wired network, network that run with cable from point A to point B, while wireless doesn't have any relation with cable. You just have to connect directly to your system through an encryption or a code for it.
Okay. Okay, thank you. Do you know that, Don, do you agree with me that what you just said, like 90% of those that are here, they know it? Do you know?
Yes, sir.
Good. So now, the reason why I actually called upon someone to talk is because we are going to see some deeper things that maybe some persons don't know in our conversation. Now, Don, do you agree with me that? Okay, no, before you even agree with me at all, which one do you think is going to be faster? Wired or wireless?
Wireless.
Think very well. Think very well. Don't make mistake. Okay, why do you think wireless will be faster?
I think it will be faster because there will be no bridge of network or thereabouts. Just like unlike the wired one where maybe there will be issue with the port or whatever. I don't know. That's just my thoughts.
Okay. I don't agree with you, but let's hear from let's hear from another person. I would don't okay, you can off your mic, but I'm not going to mute you, so you can always come in again. Let me call because I never called before. Let me call Zeus. I think I've called Zeus before. Let me call Maurice Efpo. Maurice, which one do you think is going to be faster, wired or wireless? Maurice.
Hello, can you hear me? Can you hear me,
I
sir?
can hear you.
Okay, I think wireless network will be faster because when you're using your
Maurice, your network is very bad. Trust me. Trust me, your network is very bad. I had to mute you. I'll be calling the last person. Okay, Zeus. I finally have to call your name. Your face just keep showing up. So, which one do you think is going to be faster, wired or wireless network? Unmute yourself and talk, please. We can't hear you. Okay, we can't hear him. So let's just proceed. Now, there's actually like a little bit interesting topic. So, wired network is actually going to be faster than wireless. Let me give you a typical example. Say you want to send something via Bluetooth or I know if I say Zenda now, some of you will be very quick to say, wireless is going to be faster. But I'm telling you with all certainty that wired network is actually faster. Now, let me use this thing to explain. Ethernet cables. If you talk about Ethernet cable, when you are connected to like an access point via Ethernet cable, and when you are connected wirelessly to the access point, trust me, the wired one is actually faster because of what it has higher bandwidth. So anything you want to do is faster. If you don't believe, just have to believe now. Like if you've always known otherwise, just agree with me that wired is always faster. So let's look at what we have in the material. So for wired network, we can always go through everything there in the material. So that's the history. We have the history of the internet. We can all look at everything that we have there. Now, our area of interest, network security devices. We talked about firewalls in the previous class, talked about IPS and IDS, that's intrusion detection system and intrusion prevention system. I need someone to explain to me what I said about a firewall. Okay, someone please. What I said about the firewall. I know we already talked about it in the Cisco class that we did before. Okay, Tomiwa Henry, what's a firewall?
Can you hear me?
Yes, I can.
Okay. You made an example that day when you were explaining it. You said, let's say there's a fire burning outside, then there's a wall protecting you from the fire. Like let's say you are inside, there's a wall protecting you from the fire. That's firewall in general. That's as an example. It's a protection method.
Toma, it's not a method. I don't know if you are done. It's not a method. It's a protection, but I need to use the right term. I don't know. I can't hear you. You're trying to
Can you hear me?
talk, but I can't hear you. Yes, I can hear you now.
Can you hear me?
Yes, please proceed.
Okay. I mean, sorry for using method. It's just like a barrier. It's a security system.
Okay, yes. Is it necessary that you are easy to listen to the call because it's breaking, Christiana, please confirm if you can hear me well and you can't hear him well.
I can hear you very clearly, so I don't know. I can hear you clearly.
What about Toma? Can you hear Toma?
Sorry? You just slightly wasn't clear, but
Okay. Just want to be sure it's not
right
from
now.
my.
Yeah, I'm sorry. Maybe because
Just want to be sure. Oh, yes, started talking. Just wanted to be sure. But Thomas said it well from the example he gave. From the example he gave, he made reference to what I said earlier on. So it's correct. If you want to call it a device, if you want to call it a system, security system, either way you're correct. So they monitor, or let's just use the word they control incoming and outgoing network traffic based on what predefined rules. You must have defined the rules yourself. So we have different kind of configuration you can give your firewall. Yes. Oh, please, before we do different types, there are different types of firewalls also. We have the hardware firewall, software firewall, cloud firewall. Now, we already know the meaning of hardware. We don't know the meaning of software. Like when you say hardware firewall, definitely is a physical device, one that you can see and touch. Yeah, it definitely filters traffic between two or more networks. Software is not a physical device, it's a program that's probably installed or something. Now, cloud is the one that is installed. It's hosted on the cloud. Now, apart from antiviruses, we designed viruses that could be detected with antiviruses. Apart from antiviruses, you see, firewalls that we have nowadays, they can actually detect encrypted attacks, malware. Not only malware signatures, and even block phishing attempts. Just that I didn't really have enough time. Ordinarily, I should have come down to look at the LinkedIn post that some of us gave. There's a way you're going to explain something. It's going to show that you truly understand it. When you talk about like signatures, how your antivirus was able to detect that signature from, I think one of you use ACAR tests for your virus. So if you can explain this stuff, because you never can tell who's reading your post, who's going to be interested in your post, and seeing the way you are sensitizing the public. So that's that on virus. That's that on firewall. Moving further, we have IDS, we have IPS. So you can read that up. Next on our list is port number. Please, this one is very, 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 very important. Let's get there first. It's very, very important. Port number. I don't know why my PowerPoint is taking time to load. Please, 1 minute. Okay. Okay, good. Please look at the screen. What you can see there, network addressing and port numbers. Please and please and please. It's very, very important. See these aspects. You see, if you don't understand all those things I've been saying before, maybe network address, firewall, all those things, you might not really bother much. You might go and read that one later and you understand it perfectly well. Now, what we are entering is the main deal: network addressing and port numbers. I might not necessarily talk about what you have on the screen, because what you have on the screen is what you can always go and consume during your leisure. That's anytime you like, you can go and consume it. Sorry, 1 minute. Okay, now so you say look at the screen, network addressing and port numbers. You said look at the instance created here. You want to stream a movie on your computer? All of the video from the remote streaming video server reach only your computer and not your neighbors. Now the answer is that every computer on the internet must have a unique address. Now that brings us to what is known as IP address. I'll talk about IP address in detail. Now, IP address IP means Internet Protocol. It's the unique identifier that is assigned to a device on a network. So it allows the device to send and receive data on a network. Now see, like what you have on the screen, every computer on the internet has a unique internet address, also called an IP address. It's always 32 bits long and has a format A.B.C.D between what? 0 to 255. If they ask you what's the popular IP address that you know, some of you will say 192.168.0.1. Yeah, it's just like that because don't worry, we'll get into that. That's the popular one. But the truth of the matter is, see that place that you have 192, any number from 0 to 255 can actually stay there. Now, every network application on the computer has a unique port number. Every network application has a unique port number. So you see HTTP, that's a unique port number as port 80. HTTPS, that's one that we use to browse normally. That browse various web pages. We use HTTP to browse, but it's not advisable. As a matter of fact, Chrome said will not even load up HTTP page. They tell you that I should want to proceed. That kind of thing. If you not say yes, you still want to proceed because HTTP is not secured. HTTP uses port 80. HTTPS uses port 443. So now those port numbers, they disambiguate the addressing of networking application when multiple applications are running on the same computer. E.g., web servers are usually assigned on port 80. So to reach a web server at the internet address, we must add our network data to both the internet address and the port number using that notation that is given to you there. So in essence, what it means is that ordinarily, if we want to browse a particular website, that's the particular website we want to visit. If we know the IP address, the way we are supposed to write it is, let's say the IP address is 1.1.1.1. The way we are meant to write it is 1.1.1.1:80. But I'm sure if normally now you know Facebook as www.facebook.com. If you don't know it as www.facebook.com, you're not going to know it as 1.2.1.3:8. You know that now it's more difficult now. That's where DNS now comes into play. Domain name system. I think system or service. I'll check it when I get to later part of this thing. So I need you to understand like IP address and port numbers. So just know that any application, any network application, not just application, any network application, it has a unique port number. Okay, so it's already 4 o'clock now. I would open the session for attendance.